Okay, let's work on newCTFE again. And I have been refactoring the way that arguments that come in are translated into the internal data structure that CTFE itself uses, newCTFE uses. And there seems to be an issue here where when a class is nested inside another class, it doesn't do the right thing. So let me show you that. We can use reflection to create classes that are nested inside of other classes. And now that's better, right? Easy to read. Like I said, we can use them to create classes nested inside other classes. Let me for now create the case where this happens with the custom thing. So test class reference expression. So here our class reference stuff works. However, once we start nesting another class in here, and let's say, for the sake of argument, that in the constructor we initialize it C1. Let's say we'll assign two fields here. That would recur, right? Right, so let's set C1 to this. So inside this class we have a thing that points to itself, and that will also help us debugging the printing out of these things. Yeah. Okay, now let's run this. Test class ref. And we get a range violation pretty much immediately. And let's see if we don't initialize it, if that is still the case. Yeah, so that initialization will crash CTFE immediately. And I don't think that it even... I don't think it should. So let's remove the calls here. Right, and let's now try doing that at runtime. Like instead of having core main imports, let's see, cores to C, and let's do the same thing. Let's, I think it was equal to R. that did that. So yeah, because the call to R calls the constructor. And I'm curious whether this would crash at runtime as well. So no, this doesn't crash. Could even do field 1 putter, and that should know. That now does the right thing. And if you do static slash R 1 2 field 1 equals 1. This would fail, right? Oh, it doesn't? It doesn't fail. However, if I didn't pick out the first thing, yeah. So we'll just do this. If I static assert that a class comes back, right? I can just do assert that it's not null. Oh, it just has to do with the expression sitting there. Is that the reason? But I wonder what's going on here. So let me have a quick look. That's not the bug I wanted to debug, but it is a bug, so I may as well debug it. So we create inside the interpreter D enable. There is now an invalid token because something is treated wrongly, I guess. So PE to cars. Okay, E to cars doesn't work. So that already breaks. And the reason why it breaks is I assume sleeve. Okay, can I do this? Can I have the struct literal exp? The struct literal exp, that one works. I wonder if that's a regression. Let me quickly check if it could be. That's why we have run.debugging.org. Run dealing, I don't know, I guess. So we have this. And we want to do this with all the components that we know. Okay, that thing, I can fix it by copying in the definition. It's not like this is gonna kill anyone. But I don't think that has to do with the issue. Expression is not constant. I mean, it creates a pointer to itself, but it is certainly constant. Like, I can assign this to a thing, and everybody's fine, right? So, oh wow. With C. This is a great one. I love it. It has so many things. So since 292, since 293 we are sec faulting. 292 was able to do it. And then we are sec faulting again. So this one failed on, oh yeah, because not one, it's one. So this broke in 2085. Yeah, I think we can trim this example down. Let's drop this one at all, I think. Like that, I believe. Okay, so it seems like the rest was needed. So yeah, so this has the desired characteristics. So now let's remove this base class. Do we still have the desired characteristics? Yes. Into 841, this starts fading. I would like to know if I can. So this is one thing that fails, that causes something else to fail. This is quite interesting. I wonder if it fails with my Yeah, that fails. Doesn't say anything. No, it just segfaults. But in 20841 it wouldn't fail. So this is interesting. Do I have dust mite? Yes. Every time I use dust mite I have to look it up. Dust mite, segfault, detecting a specific segfault. Detecting a segfault. Detect just any segfault. Alright. Mkdir, repro. Okay then. Ref, repro, star. Let's just copy the offending file into the repro folder. Then do script sh. Copy this. Bin bash. And I want to do segfault with both the DMD that's on here and with I don't think that there needs to be else. There's just a fly. So we fall through and exit with 1 if that doesn't happen. And then we have here the other invocation, which is generated DMD generated Linux release. Probably like that. I believe that's it. So do dust mite. Okay, it's a program, not script. Dust mite repro script. Repro result. Repro reduced. Whatever. What would that be? Because we can't even find it, huh? Okay. That would be a reason. No. Oh, just as me doesn't fail with. Yeah, it does fail with like a dollar question mark. One is a set fault, the other one is a range violation. One. Okay, let's see if we can reduce this by even a little bit. Retro reduced. Yeah, so this will segfold. The compiler. This is interesting, huh? Let's see how well this repros in all the compilers. Yeah. So cannot implicitly convert expression. Cannot have C1 to immutable. Oh. I can fix that. That should work. Now it should compile on more versions of the compiler. Let's put this one in. Let's file an issue. DMD regression. As far as I can tell, that's all. It's on all. The thing is, recursive class. Regression. What was it? What was the last one that could do it? 2084. One recursive class literal so for the compiler, that works. Let's submit the issue. Now that we have done that, let us try and focus on the actual bug that we wanted to fix. I'm really quite amazed by this. Well, there we go. Let's rename that into issue 2229. Well, we can just remove the whole thing. Script. Yeah, that was fun. Now for the actual bug inside my inlet system and not in the main compiler. So what we want is a class inside a class. It should be relatively easy to do. We just have the class C1, which contains C2, and has a string name in it, and C2 also has name in it. String name. We'll have a constructor. This, pure this name. No, can't. This C2 equals C2. And here we have almost the same. Just without this and without this. And then we have a function static mutable which returns a C1 and we want a function, so yeah, functions are always static and mutable, you cannot change them. F string f1 name 1 string name 2, and then we do C1 equals, we have to do the C2 first. C2 equals new C2 name, and C1 equals new C1 C1. Let's do here N2, and here we do N1 comma C2, and we return C1. So now if we do pragma message F hello world, we should see that this should work. If you don't type or anything, that is. So now we have a class and it works, and it's great. Also works with the compiler that I have, but now I passed a newCTFE flag, and that actually also works. Kinda. We see one change, which is the world just got swallowed. And when we do something that just echoes a class literal like that, C1 E gets a C1 pure. This one too, actually. And then we do, all it does is return it. Like, all I do is returning this thing, and now we want to see what's going on. So we do pragma message E of F of return this. One more. So now, when we do the return this here, we see that the class literal here has a null in its string member, and when we are interpreting this call. And I'm not 100% sure why that is. We say attempting to eval E, then we are attempting to eval F. We're generating the bytecode for F. We are executing the bytecode for F. We're converting this to a class reference. Then we have interpreted that call. We're generating bytecode for E. And now we are creating a class literal from the botched one that we already got. Right? We now went through newCTFE 2 times. Which we can see by newCTFE botching this. Right? So it got a completely fine thing, right? And it botched it. So, question is, will it botch it if it gets a well-made? If it gets a well-made constant. Where we can be sure that this works. I can just static C1 equals C1 immutable new C1 good comma new C2 manners. I think this should work. So until I can have a static initializer. Oh well, yeah, it has to be static immutable. No. Alright. Const comes in, const has to go out. So, right. So we now have created a proper thing, and now I want to just echo the correctly created class literal C1i here, and I get a failure because the thing that constructs the class literal from the arguments, it cannot see this, or rather it doesn't know how to deal with it. Perhaps we do this first, just so we have a better way of dealing here. The way where we would need to do this is here, and I think that there is a place where we do, where we work on these symbol offset expressions. But perhaps there is not. So, okay, then let's write it, I guess. What we do is basically the same as we do in here, except that it's completely different. So this is a var exp. Var exp can have different things in it. Yeah, var exp can have different things in it. For example, if var dot. So it could be a function declaration. E dot var dot is function declaration. It could be a variable declaration. Actually, that's the most common thing. Or it could be somebody else. But oh yeah, and it can be a symbol declaration. We want to know what's the case, so we did print %s. We do fd That's exactly what we want. VDSD, and then we would at least know what's going on. I don't think so. And then we can see what's happening hopefully soon. I was like, why does this work? Because we commented everything out. Okay, this sec false. I don't know why. Yeah, alright. If you copy paste code, make sure to change all the copies. There we go. Now we have to wait a little bit for the compiler to compile. Isn't it annoying that it takes so long? Granted, it would be faster if I used DMD to compile itself, but still. Alright. Wait, now it succeeds? Oh yeah, it succeeds because it gets null expression instead of anything else. Right. That makes sense why it succeeds. Because we just, whenever we get a variable expression, we say, yeah, it's null. Don't worry about it. Okay. That is, of course, not what we want to do. You can even see it generates the argument. It comes out as null. So what we have in here is a var declaration. I do not really want the visitor here to have to deal with anything that's not a declaration. That's not an expression. So I will simply special case the code for this, and so we do not have a visit for var declaration in here. And I hope that I can do that. So we now know that there is a var declaration. So we can say if vd, we special case our code. We know that a var declaration has a declaration in it. So that means the var declaration, we assert that it has an initializer. So we say vd init I hope that's the real field. It's not. vd init. We assert that it has an initializer because there is no way that it couldn't have one if it is allowed to be used in a static context. So what we then do is auto e equals vd init is exp initializer exp I. Then we assert that that's the case. And then we use the exp to initialize sub exp I vd is vd. There we go, and for that we have to import dmd as type name. So if it's not an expression initializer as we expect, we would assert and get an error, which means we think that it is an expression initializer, which now means that I can just say expi.x.accept this, and this will then generate the result. So this one goes the way of the dodo, and that should then just give me the expression that is in that variable initializer, and with a bit of luck, this simply works. Given you use the right compiler. Well, it doesn't simply work. We cannot handle the expression new expression. Okay. That's fair. That's fair. What we have to do then is we have to run CTFE. Okay, let me simply run the old interpreter on that for now. And there we will do the cheesiest thing possible with interpreted or static interpreted is e.ctf interpret and then we say expression interpreted, then we say interpreted dot this and not this dot accept this, and we call it a day. And that would go through our class literal thingy, class literal expression thingy. So we have the old CTFE engine do the new, and for like static things we will do the new, we will do that interpretation ourselves in the future, but for now we just use the old CTFE engine for this, and we see that the class that is inside there is somehow messed up. It doesn't seem to be able to generate to put its own string in the initializer. So the way we deal with nested class reference expression is messed up. And the question is now, is it that we mistreat the argument? And that does seem to be the case. Because all we're doing in this example is running on a class reference expression that has already been created for us by the old interpreter, and that is wrong. So what we have to start debugging is the class reference expression stuff here, and one of the interesting things is that I wonder if it has to do with nesting level only. That is, could I use an array of strings in there and would that work? So if I do this, string array names, then I have this good and cheerful manners, where I have to change what f does to put a array literal around. E doesn't have to be changed, so yeah, that should work. And now we see that this is just completely messed up, right? Like when we had a string in here before, and I can still have this, right? And I just take names. Right. This again is when the constructor doesn't check that you use all the arguments. You just make a typo and it affects you forever. So yeah, so this comes back with a null, right. Okay, so the first field is being treated properly when it is a string. When it is an array, it doesn't do anything. So now we see an empty string in C2, right? Whereas when I enable this, we see a null in C2. And there's a difference between a null and an empty string. A null means there's a null pointer, and an empty string means you point to either a valid or an invalid pointer, but you point to something, and 4 spaces after that, where the length is expected, you find a 0. So empty string literals can also be created by pointing into garbage as long as the length is 0. Which is just how it is. So I would expect that both of them completely point into garbage. And the first string, the literal, is being done properly here. But as soon as I remove the first field from C1, so if I change the layout of C1, it represents null. So this seems that names, if I say names 1, what I see cheerful. So this, the string array makes it in here just fine. So if I had now a second one where there's an empty string array, I would expect to see first name there and an empty array in the other one. So clear. Now we see good null C2 null. Whereas when we had the array, so we know that the array literal here, right? That thing comes in properly. Well, the whole creation of the new expression here, that is being done by the old CTFE engine. So we know that that works. But we know that this is a valid class reference expression that we run our thing over. That's fine. that's okay. So I would say let's do debugging printf here. I would say converting class ref x colon send s comma 3.2 and as long as we do not anything recursive, that should work. And we should be able to see that we are indeed getting the literal that we ought to get, and that is what we should see. Okay. So I see I'm converting the class ref expression of good and cheerful manners, and then I'm converting the other one as part of this one, which is the C2, right? So my guess is that converting this one actually overrides something in here. So I would guess that if I now remove the C2 from here, from that, if I do that, then I would get name and names properly. That's not the case, maybe because there is still a C2 in the arguments. So let's do this one. Let's do null instead. So this is interesting. We see the first field is being put in properly. Yeah, but that does not hold true for the array literal expression. So let's do that for the array literal expression as well. Here, array literal expression. And then let's see if that, so we should, there's no cree, that's no cree. Then we should see, I mean that has to come in properly because it was formed by the old CTFE engine. So we do not expect that to fail. But what I would expect is, okay, the array literal expression goes in, we have good and cheerful, and just to make sure that we are not completely completely going out on a limb, maybe const string right, key const string array s returns s, and then we have a little pragma message e strings matter. We have an array literal expression strings matter that's being converted that is fine. So we see that if we put a string array, that works. That by itself works. However, once we do that inside a class ref, it fails. And the question is what's going on. So, in the case where we get that, we compute the length, blah blah blah, here is where we differ, which is that we say our memory starts here, and we assume that we have space. We assume that we have space to put the array elements there. However, if it's a dynamic array, right? If it's not a static array, then we won't have the space. Like if this array type isn't true, then it's not a static array. And because we don't have the space, we just override somebody else. And that would be consistent. So let me now force. This now means we have a static array in there, right? This should still work. This won't work. Interestingly, we already fail at converting the static array from the thing we have. Like this is almost as if we wouldn't write the correct length inside the array descriptor. Our base starts at the place after the array descriptor, and we push the array descriptor. The array descriptor writes the base and the length at the place we are pointing, right? So I am confused in regards to where these things are put. So I push this slice descriptor, and then we are in treating the array. And I happen to know that the expressions in there are strings. I know that the offset that I compute is the offset that I expect. Okay, let me take this scope exit code and put it down there, because when it's up there I can't read it. So this is what we do after we've created the result. We ask, well, we ask so we are not inside another aggregate, right? Printf our memory and I would guess that and why do we create tab? Well, it doesn't matter really. Yeah, so this array literal expression we want to put into our memory. the same should happen when we have the strings matter 1. Yeah, we put it into our memory, and here we also say we want to put it into our memory. However, we are inside creating members for the class reference expression. So it wouldn't make sense to put it into our... Oh. Do I just have to change this to an aggregate? Is that all it is? Because it was just asking for whether I'm in a struct or not? Well, never mind then. Never mind. So, will this work? Will this work now? No. This is interesting. The literal expression good and cheerful. Right. Let me do one thing here. Let me verify that this thing could be converted correctly directly after I did it. So if it could be converted correctly, then converted me into right, because into to expression of result, and the type is any type. So that's that. This should tell me that I have converted the thing correctly. And now I know at which stage I right, true colors. So this round trips the conversion, and this round trips the conversion, and we should now know if we did the right thing. And then we know whether is the generation of the array literal or if it's the generation of the other thing. Okay. The array literal itself is not written correctly. It almost looks as if we don't have space. So this one is not written into our memory. So let me ask you this. If I write it into our memory, would this work? So the only thing I've changed is where in memory this thing is being written. And yes, if I write it into our memory, it works, and the class can no longer see it because it doesn't. It's not where it expects the slice descriptor. I believe that if this is not a static array, then the only thing we can write in here is the slice descriptor, which means we do have to, like this is only the case if we allocate the memory, right? But even if we are inside an aggregate, the only thing that's getting stored is our slice descriptor, right? We still have to allocate memory for the data that we want to point to, and that data is the size of array size. So we can just do that. We can just say array size, which first of all it's already aligned. Secondly, this call will align our memory, so that's fine. So we point the bytes at new allocated memory, and we write information for the slice descriptor in the memory that we have been given. Our offset is the base add, so I believe that if I now do and base add, that now it should work. I do believe that. And yeah, now it does work. That's great. I like it. I like making progress.